Hello and welcome to Train Signal. You are watching the Linux shell environment. Do you remember the days before GUIs hit the scene? All we had was a DOS prompt and a blinking cursor. Pretty intimidating for those early users. But when Windows came along, it forever changed how most users would interact with their systems. The X Windows system and the myriad of desktop managers moved Linux from the server room to many desktops. In truth, many of the commands we use at the command line can be done from within a GUI environment, but by now you should be growing more comfortable with the Linux command line and understanding that as an administrator, it's something that you'll absolutely need to master. In our GNU and Unix commands lesson, we took a first look at the Linux shell environment. And while there are many different shells, Bash is the one that you'll need to focus on for the Linux Plus certification exam. So in this lesson, we'll delve a little deeper, taking a look at environment variables and how they're used to configure the shell environment. We'll also review the configuration files that control the shell and how you can modify them to make permanent changes to your system. And this lesson will conclude with a look at aliases, another pretty cool tool that can help make navigating the command line just a little easier. Let's start off with environment variables on the next slide. As we've learned before, when you start a Bash shell, it uses a collection of startup files to help create an environment. These are called environment variables. Environment variables are always uppercase and in the shell environment preceded by a $sign. Below is a list of common environment variables, and you'll want to commit these to memory. The first is user or username, which holds the current username. Shell holds the path to the current command shell, in our case Bash. PWD holds the present working directory. Hostname holds the system hostname. Path will hold a list of directories to be searched when running commands from the shell prompt. And home holds the path to the current user's home directory. Continuing with our list of common environment variables, next we have mail, which holds the path to the current user's mail spool, or in this case var spool mail followed by username. LANG holds the language, which is specified as a locale. LD underscore library underscore path indicates where library files can be found. PS1 holds the default prompt. And with this variable, \u will indicate the username, \h will indicate the host name, and \W will indicate the current working directory. Next we have NNTP server, which specifies the name of news server systems. Then we have term, which holds the name of the terminal type, followed by display, which specifies the X display, usually indicated by :0 followed by another 0, if you have one display. And finally we have editor, which specifies the default text editor. On the next slide, we'll talk about how to display and set environment variables. Now that we know some of the most common environment variables, curious minds probably want to know how to manipulate these settings. If you recall from our GNU and Unix commands lesson, you can display the current variables two ways. First by typing env at the command line, but this list could get long, so if you want to know the value of a specific variable, you can use the echo command, or echo space $sign followed by the variable name. Let's open up a terminal window and take a look at some of our test system's environment variables. Let's go to Applications, System Tools, and Terminal. Now first, let's take a look at all of our environment variables by typing env. And as expected, we have a rather long list here of variables and some other information. So let's take a look at some specifics. Let's type in first home, and remember we need to precede the environment variables by a $sign, and it needs to be in all caps. So first let's type in echo space home and hit enter. This tells us the path to the current user's home directory, which in my case is home v Henry. Now, what if we wanted to know the value of our system's path variable? For that, if you recall, we type in echo space $, and path in all caps again. And hit enter. And we can see that the list includes user local bin, user bin, bin by itself, and quite a few others. And again, these are the directories that Linux will search for the executable file when you type in a command at the command line. Next, let's see what's listed as our current hostname. The appropriate environment variable is, of course, hostname. So let's use our up arrow key to bring up a previous command, and we'll take out a few lines there, a few characters there rather, and just type in hostname. Hit enter, and we can see that my hostname is Veronica, which is also mirrored right here in the prompt. And speaking of the prompt, let's look at the value of our current prompt variable. Remember what that one is? If you said PS1, you guessed right. So again, we'll use our up arrow. We'll take out hostname and type in PS1. And what we see here is a list of parameters, and we covered these on the previous slide. U, again, is for username. H is for host name. And W is for the current directory, which you see reflected here. Username is vhenry. Host name is Veronica. And the current working directory is tilde or home. Though you can change environment variables, you should do so with caution, as they can cause problems with services that are already running on your computer. Hostname is a good example of that. Now you can also set environment variables two ways: manually by using the equal operator, using the syntax variable equals value, or something like path equals var opt my program. The export command will make the variable available to programs you launch from the shell. Let's go back to our terminal window and take a look at that. Now, what if we wanted to change the prompt just to show the username? Using the syntax variable equals value, we type in PS1 equals, and for this command we need to use the quotations. We'll put in \u for username, followed by a space, followed by, let's add in the working directory as well, W, and we'll end it with a $, another space, and close the quotation. And let's hit enter. And we can see that our prompt has changed just to reflect the username and the current working directory, which is home. Now, say we had a program whose executable is stored in var opt. To change our path, we type in path in all caps, followed by the equal sign, and then we type in the new path, which in our case we'll try var opt, and hit enter. Now let's type in echo path to see if our change has been applied. And we forgot the $, so let's use the up arrow, go back over, and insert the $, and hit enter. And we can see that our path has indeed been changed to var opt. Now let's try something here. Let's type in exit to exit the terminal window. Then we're going to relaunch it. The application, system tools, and terminal. Now the first thing you should notice is that the prompt has changed back to what it originally was. Now let's try and see what the path is. Space. And again, this has also returned to the default. So as we just found out, the changes that we made are only temporary, and once you log out, they're gone. So let's cover how to make the changes permanent on the next slide. If you want to make the changes permanent, you need to modify a bash configuration file. You modify the global config file if you want the change to apply to all users, and you modify a local file if you want it to apply to individual users. Then there are also login files that are launched only by a login or non-login process. I know this probably sounds like a confusing maze of different files, but hopefully the table on your screen should make things a little clearer. Again, we have global login files, which are etc profile and etc profile.d. Then you have non-login files, etc bash rc or etc bash.bashrc. For individual users, we have the tilde bash underscore login file, followed by profile, followed by bash underscore profile. Now for the non-login file, it's bash rc. Now which one of these files that you use depends on your distribution. Let's switch back to our terminal window and see what's used on our system. First, let's clear the screen. Clear command. Then, to view the contents of a file, we know that we use the cat command. So let's type in cat space /etc/profile and hit enter. Now if we scroll past some of this other info that we don't need to worry about, we'll see that the path and hostname variables are set. You can see hostname there, and we can see some path information there. Now let's view the contents of etc profile.d. For that command, we'll type in ls space etc space profile.d. And we'll see the contents of that directory here. And if you recall, files that end in sh apply to the bash shell. And at the bottom of our list here, we see the file lang.sh. This file sets the language variable. Let's view the contents of this file by typing in cat space etc profile.d followed by the name of the file lang.sh. And we can see here that our language is set to US English. Okay, let's head back to the presentation. Keep in mind that global configuration files can be overwritten by user config files, since these files, along with others, are copied to the user's home directory when their account is created, and they can be modified from there. These are part of what's called skeleton files, and they're located in the etc/skel directory. And also, along with login scripts, there are logout scripts, and those are found at bash_logout. Now they can do many things like clean up temp files, for instance, or make security changes, but be careful using logout scripts if you have users that log in multiple times. Another bash configuration file is input.rc, which customizes your keyboard configuration. And again, this is just for bash, as X uses its own programs. You'll rarely need to modify this file though. Let's move on and talk about aliases. I was initially confused about aliases and how they were different from variables. But where variables assign a name to a command, aliases are essentially shortcuts to a file or command. This comes in handy for long or obscure command names. When you boot up, some aliases are created for you, and you can view them by typing alias at the command prompt. The image on the screen contains the output from the alias command, and you can see that there are several aliases set up for the ls command that include some display color options. So for example, typing in ls will display the output as if you've typed in the ls space _color equals auto command. You can also create some of your own at the command line with the alias space alias name equals commands command. Let's try out a few aliases. Let's switch back to our terminal window. First, let's clear the screen with the clear command. Now say you find the rmdir or remove directory command just too taxing to type out, and you'd like instead to type in rd whenever you want it to remove a directory. To set that alias, let's type in alias alias space rd equals and put in the command in single quotes, and it's rmdir, and let's hit enter. Now let's type in alias to see if this was properly added. alias, and hit enter. And here's our new alias. You can see here it's alias space rd equals rmdir in quotes. Now, to test this, let's create a directory by typing in the mkdir command. So we'll create a directory with mkdir space, and let's call it mytest, mytest, and hit enter. Now type in ls to make sure that our new directory was indeed created. And we can see mytest right there. Now let's type in rd, or our new alias, which is short for rmdir, rd space mytest, and hit enter. Now we forgot our T. Let's hit the up arrow to bring that back, and hit enter again. And now let's type in, actually we'll use our up arrow. There's the ls command, so let's hit enter. And now we can see that mytest is indeed gone. Now let's take a look at another example. Administrators spend a fair amount of time perusing their system's log files. Now, sometimes you just want to look at the log in certain sections, like the beginning or the end of the file. We've already learned that we can use the head and tail commands respectively to do so. But who wants to type in that entire command every time? You could easily set up an alias to view the last 10 messages in var log messages. First, since we know that we need to be logged in as root in order to view those log files, let's do that. Type in su for switch user. Then we'll type in your root password. Now that we're logged in as root, let's type in alias, alias, space, and let's come up with the name for our alias command. We'll call it log end, since we're going to view the last 10 messages of the log file. Log end equals, and then we'll put in tail, the tail command, tail space, /var, /log, /messages. Put in the close quote and hit enter. Let's type in alias to see if that was added. And we can see that it is here. Alias login equals tail var log messages. So we should be able to type in log end to view the last 10, and we can. Here we can see the last 10 messages that were in our log file. Now with just those two examples, you should have a sense of just how powerful aliases really are. I anticipate you'll have a ball trying this one out. But for now, let's go back to the presentation. What we just covered is the manual process, but you can make these changes permanent in the bash startup scripts we just discussed previously. And that concludes our lesson on the Linux shell environment. Let's review what we've learned on the next slide. With another lesson complete, we are moving ever closer to mastering the Linux command line. As with everything we've learned, practice makes perfect. As you go forward, testing and changing your config files, it's always a good idea to make a backup just in case something goes wrong and you need to revert back to the original. To recap, in this lesson we covered environment variables, including some common variables and how to set and change them. We then talked about how to modify the configuration files that control environment variables. And we wrapped up with a review of aliases, the shortcuts that can help shorten the commands you type at the command line. Thanks for watching, and I'll see you in the next lesson.